Okay, so in the last lecture, I I told you about the concept of modulus function, and I almost covered the modulus function. There was one thing that I missed, I could not cover, so let me cover. And apart from the modulus, there was some properties of conjugate also that I did not cover, so I'll cover those topics in this particular video lecture, and then we'll also solve a question. So in the modulus, there's a very important property, that modulus of z to the power n is equal to modulus of z to the power n. Very important property. And how do we really get it? It's very simple. Modulus of z to the power n is nothing but modulus of z into z into z into z n times. So I can write it as, split it into mod of z into mod of z into mod of z into mod of z, and this is nothing but modulus of z to the power n. Okay, so modulus of z to the power n is equal to modulus of z whole to the power n. So this is one property. In the conjugate, there were a couple of things that I missed. Okay, first is that conjugate can be distributed over the complex number. Okay, what does it mean? So first of all, let me just give you a brief idea of the conjugate. So suppose there's a complex number z is equal to a plus ib, then conjugate of z is equal to, we do not touch the real part but we change the uh, polarity of the imaginary part, the sign of the imaginary part. Okay, so this is a conjugate. Now let us discuss the property. So suppose there is a complex number z1 plus z2, and I want to find the conjugate of this complex number. So you can distribute it, and this will be equal to z1 conjugate plus z2 conjugate. In fact, I can extend this property to n complex numbers. If I want to find the conjugate of the sum of n complex numbers, this will be conjugate of z1 plus conjugate of z2 plus conjugate of z3 plus conjugate of zn. Okay, so this is one of the property, and this is valid for negative also. So z1 minus z2 conjugate will be z1 conjugate minus z2 conjugate. Okay, now sometimes instead of the usual representation, the complex number being represented as a plus ib, sometimes the complex number may be written like this: z1 plus I times z2. Now please remember, if this is a complex number, then you cannot say that this is the real part of the complex number. No, because z1 is itself a complex number and z2 is itself a complex number. So this z1 will have some real part. This will be of the form of a plus ib, and similarly z2 will be form of c plus id. So you have imaginary part here also, imaginary part here also, and there is one iota outside. So you have to multiply, and then finally the expression that you get, you will separate the imaginary and real part, and that will be the real part of z1 plus I z2, and the other will be the imaginary part. You cannot directly say. Okay, so suppose you are given a complex number z1 plus I times z2, and if you want to find the conjugate of this complex number, so what you will do, you will split z1 bar plus I times z2 bar, and please remember that the conjugate of I is minus I. The conjugate of I is minus I. So this will become z1 bar minus I times z2 bar. Okay, so this brings me to the very important property, basically distribution of conjugate over multiplication. So suppose I have multiplication of conjugate numbers, of complex numbers, and I want to find the conjugate of this multiplication. So this will be z1 bar into z2 bar into z3 bar. This property is what I've used here. Basically there are two complex number I and z, and I'm taking the conjugate. So I will distribute it over I into conjugate of z, and conjugate of I is minus I into z conjugate. Okay, so these were the some of the general properties. Further, in division also, suppose there is a complex number z1 by z2, and you want to find the conjugate of this complex number. So this will be z1 conjugate divided by z2 conjugate. Okay, let me take an example. Suppose there is a complex number a plus ib upon c plus id, and I want to find the conjugate of this complex number, this entire complex number. So I will distribute a plus ib conjugate divided by c plus id conjugate. So this will be, the real part will not change. Conjugate of plus ib will be minus ib. Similarly, conjugate of c minus id. Okay, finally the conjugate of a real number is the real number itself. Okay, and one more thing, if suppose there's a complex number z, you take the conjugate and then you again take the conjugate, so what will you get? You will get the complex number back. Suppose you have a plus ib, you take the conjugate and then you again take the conjugate, so this will be a minus ib, again conjugate, and this will be a plus ib. So if you take the conjugate even number of times, you will get the same complex number. If you take the conjugate odd number of times, you will get the complex number with the opposite sign. Okay, so these are some of the basic ideas. Okay, and conjugate and modulus can be combined together also sometimes. Okay, so suppose I have mod of z1 plus z2 and I'm taking the conjugate, no problem, just distribute it, mod z1 plus mod z2. But please don't write it like this, mod of z1 plus z2 whole conjugate is equal to mod z1 plus mod z2, because this distribution over addition is invalid. Just check out my previous video lecture. Okay, so these are some of the basic ideas of conjugate that was left. So I have covered everything. In the next video lecture I'll start with argument of a complex number, a very important concept. Okay, so stay tuned and we'll meet in the next video lecture. Thank you.